Hello and welcome to Engineer's Mindset. So in this video, we are going to be looking at rate of flow and continuity equation using this question on the board. The question says, the diameter of a pipe at section 11 and 22 are 100 millimeter and 250 millimeter respectively. If the velocity of water flowing through the pipe at section 11 is 10 meters per second, find 1. The discharge through the pipe, and 2. The velocity at section 22 of the pipe. Okay, so let us draw the pipe section and see what it looks like. So the first diameter D1 was given to us as 100 millimeter. So you can convert this to meter simply by multiplying this or dividing this by 1000. Okay, either you're multiplying by 10 to the power of minus 3 or you divide this by 1000. So if you do that as 100 by 10 to the power of negative 3, this simply gives us 0.1 meters. Okay, so that's our diameter for the first section of the pipe. For section 2, D2 was given to us as 250 millimeter, which equals 250 multiplied by 10 to the power of negative 3 in meters. So you have this to be 0.25 in meters. Let's see the section of the pipe and see what it looks like. So obviously 0.1 is less than 0.25. So at the first segment we have 100 millimeter or 0.1. So you can simply use this. Okay, let's represent the pipe with this. So this is the first segment of the pipe. At the second segment of the pipe, we'll have 0.25 millimeter, 0.25 meters, which is 250 millimeter. And you can simply call that this, so much larger than the first pipe. But two of them are actually connected. So connect the first pipe and here you connect the second pipe. So you see the disparity or the difference in diameter. For the first segment, our diameter D1 was given to us as 0.1 meters. For the second segment, which has a larger diameter, D2 was given to us as 0.25 in meters. So this is what the pipe section looks like. So this is section 1, and this is section 2, as indicated in the question. This is section 1 and section 2. Now we are told that if the inlet velocity, if the velocity of water flowing through the pipe at section 1 is 10 meters per second, so the velocity at this section V1 was given to us as 10 meters per second. We are asked to find the discharge through the pipe and the velocity in section 2. So we have to find V2 unknown. Now this brings us to the idea of continuity equation. If I have a fluid flowing through this pipe, it is still the same fluid that flows through the pipe that goes out of the pipe, irrespective of the size of the pipe. The only thing that changes now is the speed of flow. But the fluid still flows, it's still the same fluid that flows from this inlet to this outlet, only that the speed of flow at the larger portion will actually drop. So you're going to see that when we finish this calculation, the speed of flow V2 at this portion will be less than the speed of flow at this point. Since this diameter is small, when diameter of a pipe is small, the speed becomes larger, but when diameter of the pipe is large, the speed becomes smaller. Okay, but to do this, we have to employ the continuity equation. What is the continuity equation? The continuity equation simply states that the rate of flow or discharge of fluid at a given segment of the pipe is equal to the discharge of the fluid at the other segment of the pipe. So since we have two segments of the pipe, section 1 and section 2, therefore the discharge through section 1, Q1 is equal to discharge in section 2. So Q1 is simply equal to Q2. What then is discharge? Where discharge Q is simply what? Area times velocity. So this simply means that the first discharge becomes area 1 times velocity 1 is equal to second discharge area 2 times velocity at segment 2. So in this question, we can be able to find the area since we have diameters of each of these pipes. We can find the different areas since we have the diameter, and as such, if we can do this, we can also compute we can also find the second velocity since we know the first velocity or velocity of flow in segment 1. Okay, so let's start by calculating area. Area 1 is given simply as by formula pi diameter 1 all squared all over 4. So this is equal to pi is 3.142 multiplied by the first diameter was given to us there as 0.1 meters. So multiply by 0.1 all squared. Okay, divide this by 4. So with this, we can find the first area. A1 is equal to, so I'm going to multiply everything at once all together. So do well to point along with me to avoid calculation errors. All right. So this gives us 7.86 by 10 to the power of minus 3 in meter squared. So that is the first area. Again, area 2 is equal to pi diameter 2 all squared divided by 4. Once more, pi remains 3.142 multiplied by the second diameter was given to us as 0.25 meter. So we have 0.25 all squared divided by 4. So this simply implies that area 2 is equal to, I'm pointing all together, do well to point along with me. Okay. That gives us 0.049 in meter squared. Now, having found the areas, you observe from this equation that we can make V2 subject of the formula, that is the speed of flow in pipe 2, since we know the speed of flow in pipe 1. So this simply implies that V2 is equal to A1 V1, okay, divided by A2. So with this formula, we can be able to find the second speed in pipe, or we can be able to find the speed of flow in pipe 2 or pipe of section 2. Okay, so this simply implies that V2 is equal to, we have A1 times V1, and A1 gave us here as 7.86 by 10 to the power of negative 3 multiplied by V1. V1 was given in the equation as 10 meters per second. So multiply by 10, okay, divide by A2 was given here as 0.049. So divide by 0.049. This means the speed in pipe 2 is equal to, now let's obtain this multiple. 7.86 multiplies 10 to the power of negative 3. So this simply gives us 0.0786 divides through by 0.049. Okay, so with this, let's find this division and obtain the value of the speed of flow in section 2. So this value divides 0.049. So that gives us V2 to be approximately 1.6 meters per second. So the speed of flow in section 2 is 1.6 meters per second. So that brings us to what I said earlier. When the diameter of the pipe is large, the speed of flow becomes smaller. So you see that the diameter at section 2 is 0.25 meter or 250 millimeter, whereas the diameter at section 1 is 100 millimeter with a speed of 10 meter per second. But now observe the speed in section 2. The speed in section 2 now reduces to what? 1.6 meters per second, which is way lesser than the speed in section 1, which is 10 meters per second. So keep that in mind. When diameter of a given pipe section increases, the speed of flow in that section reduces. So that gives us the velocity in that section. Now, the first question actually says calculate the discharge through the pipe. And I told you earlier that discharge simply means area times velocity. So since we know the speed in each of the sections and we know their areas, we can either use the section 1 to calculate the discharge. That discharge remains the same as discharge in section 2. So it's either you're doing A1 V1 or you're doing A2 V2. Whichever you multiply gives you the discharge, because from continuity equation, discharge in section 1 is equal to discharge in section 2 for the flow to be continuous. Okay, so we can do that here. Okay, so discharge, you can use Q1 is equal to A1 V1. So that is equal to, we obtained A1 earlier here as 7.86 by 10 to the power of negative 3. So we have 7.86 by 10 to the power of negative 3 multiplied by the speed in section 1 is 10. So multiply by 10. So this simply implies that discharge through the pipe Q1 is equal to 0.0786 meter cube per second. Mind you, the unit of discharge is simply meter cube per second. But just to confirm this equation, let's check out with Q2, which is A2 multiplies V2. So this is going to be equal to, we obtain A2 over here as 0.049. So we have 0.049 multiplied by V2, and we obtain V2 there as 1.6 multiplies 1.6. If you do this multiplication, you're going to obtain the discharge in section 2 to be 0.049 multiplies 1.6. Again, you have 0.078, okay? 0.078 for meter cube per seconds, which is not much difference from the very first one. So that brings us to the continuity equation. Discharge through a given section of a pipe is equal to the discharge through another section of the pipe. So far the pipe, the two sections are connected together in the pipe. Okay, so discharge through the pipe or flow through the pipe remains the same. The only thing that changes is the speed of flow depending on the diameter of the given section. All right, guys, so that's it on flow rate and continuity equation. I will see you in the next video with more and more tedious examples on flow rate and continuity equation. So I hope to see you in that video. Do well to like this video, comment nicely, share to your friends, and if you are new to the channel, do well to also subscribe and turn on your notification bell to keep getting updates when new videos drop. I will see you in the next video. Thanks.